On this video, we're going to learn about straight line angles and vertical angles. So angles that are on a line together add up to 180 degrees. Another name for angles that add up to 180 degrees is supplementary angles. So you can see this little diagram down here. We have this side is 135 and this little side here is 45. So if you can see it in color here, it's red and it's green. So they kind of color coded that so we can see it. So if I add these two together, I'll get 180 degrees because they're on a line together. So they go all the way across the line. You can see this circle goes from one side to the other. So if we think about a circle, that 180 is halfway around a circle. So this is a semicircle. It's halfway. Not going all the way around, but just halfway. Vertical angles are always congruent. The symbol for congruent is here. We have an equal sign with a little wave above it. So that's the congruent symbol. So a vertical angle is going across a vertex. So it doesn't have to be vertical. It's just the name of it. But it's anytime I have two lines crossing, I go across the vertex and those angles will match. So we have 3 and 1, which I matched in purple here because we have the purple color. And then I have 2 and 4 because, again, I can go across the vertex and these two will be congruent to each other. And remember, congruent means the same size and shape. So if I know the angle measure for one, I know the angle measure for the other. And then I can actually, using the straight line angle, if I know the angle 4, I could find angle 1, 3 or 1 also because I could figure out what it is based on the 180 idea because I can subtract from that. So we're going to go ahead and practice that. So in this first one, we have two parallel lines and they're cut by a transversal. We did have a video on this one. So if some of these properties don't sound familiar, definitely go back and watch that video so that you know what those properties are. Because we have 3 main properties that we can use if we have two parallel lines cut by a transversal. We have alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. So we can use those 3 things based on the parallel lines with a transversal. So let's go ahead and label our given information. We have angle 6 is 43 degrees. We want to try to figure out how to get angle 6 down so that I can figure out what angle 1 or angle 3 are. Okay, so we need to figure out how do I bring this measurement down? Well, if I use corresponding angles are congruent. And we learned that on the last one, and they're in the same relative position. So this 6, this is on the, we can call this the right side of the parallel line, and it's above its transversal. The transversal is the one that goes through the other two, so it goes through the parallel lines. So it's above the transversal, and it's to the right of the parallel line. I want to be able to describe another angle that same way. So I want to stay above the transversal, but I want to go to the other parallel line and find the angle that's to the right of it, which is angle 2. So angle 2 must be 43 degrees. And we can see this. I'm going to show you the angle 6, and it can slide down, and it looks like it fits right there on top of angle 2. So just kind of a nice little visual there so you can see that. So angle 6 and angle 2 are corresponding angles. They are congruent. They're both 43 degrees. So now that I have this 43 degrees down near the 1 or near the 3, I need to figure out how do I use that to find out either 1 or 3. So if I think about what we just learned about a straight line, so here's a straight line, the angles that are on the straight line together add up to 180 degrees, right? So we have straight line angles add up to 180 degrees. So if I take angle 1 and angle 2 and I add them together, I'll get 180. Well, I know what angle 2 is. It's 43 degrees. We just found that. So 43 plus angle 1 equals 180. So if I subtract the 43, and I subtract it from both sides since I have an equation here, 43 minus 43 cancels. Angle 1 drops down, and I have 180 minus 43, which gives me 137 degrees. So I know angle 1 is 137 degrees. Now, how do I bring that over here? Now, I can do the exact same thing I just did with 1 and 2. I could do with 2 and 3. I could draw a little line going across here, and I could do the same thing. Okay? But I don't have to because we also learned that vertical angles are congruent. So if I go across the vertex here, because we have an X, right? The two lines are crossing. I go across the vertex, angle 3 is going to be congruent to angle 1, which we just found out was 137 degrees. So they are both 137 degrees. All right, so we're going to look at another example here. So now we have a little bit more of an algebraic example because we have 5y minus 51, but we still have two parallel lines, and they're cut by a transversal. So first, here are my parallel lines, and we're going to look at alternate exterior angles this time, because since I have parallel lines, this 5y minus 51 is on the outside of the parallel lines. It's not in between here, it's outside. And so is this 84. And if we notice that this is the transversal going across, it's the line crossing the two parallel lines, it's on the bottom of the transversal, and this is on the top. So it's on alternate sides of the transversal. So we have alternate, and they're exterior angles. So if we remember alternate exterior angles are congruent, then 5y minus 51 has to equal or be the same as 84. So this is 84 degrees, this angle. So now that I know that, I can go ahead and say, well, 5y minus 51 equals 81, and I can solve this equation for y. So I'm going to add 51 to both sides, so that I'm starting to get y by itself. So 5y drops down, the 51's cancel, and I have 84 plus 51 is 135. So now I'm going to divide by 5 on both sides. So 5 divided by 5 is 1, and 135 divided by 5 is 27. So now we know y is 27. That was one of the questions. We also have to find z. So if I know that this is 84 degrees, and we just used this in the last one, 84 and z, if we look at these two, they're on a straight line, right? So remember, straight line angles, they add up to 180 degrees. So if I add my 84, which is this 5y minus 51, but I know it's 84. 84 plus z is going to equal 180 degrees. So if I subtract 84 from both sides, I'll find out what z is, which it is 96 degrees. All right, so that was using a couple of new properties, our straight line and vertical angles, along with parallel lines and transversals. I hope that helped, and I'll see you in the next video.